squared over x squared plus 1 all squared dx. But that's a little tough one, is that right? X cubed e to the power of x squared over x squared plus 1 whole squared dx. Now the clue here, if at all there is a clue, you need to pick a dv that can be integrated. Now, you see the denominator x squared plus 1 all squared. Now, when you have a denominator with x squared, in order to integrate it, there must be an x on the top. Why? Because if you want to make x squared plus 1 equal to u, then 2x dx will be your du. That means you need to replace an x dx. You need an x on the top to integrate it. And therefore, look at this and say we can choose x over x squared plus 1 to the power of 2 as our dv. Why? Because that can be integrated. You see, let me write down that for you. You see, the quantity x over x squared plus 1 to the power of 2 can be integrated. Now, why do I say it can be integrated? Because of the denominator x squared plus u, we can do it by a simple substitution. Now let me show that quickly for you. We make a substitution, x squared plus 1 equal to u, which gives me 2x dx equal to du, or x dx equal to du over 2. Now that will make this expression as x dx. This is, of course, that x dx will be du over 2, and x squared plus 1 is u. That will be 1 over u squared du over 2. That means you can integrate it like this. Alright, let's move on and pick our u and v. Now, I was explaining why you got to look at the dv form, a form that can be integrated. What is the form I said that can be integrated? X divided by x squared plus 1 all squared. That must be the form that you take as dv. So your dv will be x over x squared plus 1 all squared dx. That means your u will be then x squared e to the power of x squared. Is that right? So we decided on our u is x squared e to the power of x squared. I hope you understand why this became u, because this x cubed we wrote as x times x squared, and the first x we took along with the dv, x over x squared plus 1 to the power of 2. Alright, if you have your u, then you got to find your du. Let's find the du. Du will be, remember, it will be x squared times the derivative of e to the power of x squared. What's the derivative of e to the power of x squared? So that will be x squared times the derivative of e to the power of x squared. Remember, the derivative of e to the power of anything will be e to the power of whatever that is times the derivative of that quantity. So derivative of e to the power of x squared is e to the power of x squared times the derivative of x squared is 2x. So we are using the product rule there. To find the derivative of x squared times e to the power of x squared is x squared times the derivative of e to the power of x squared plus e to the power of x squared times the derivative of x squared is 2x. I hope you understood this. If u equal to x squared e to the power of x squared, du is, find the derivative of this, x squared times the derivative of e to the power of x squared is e to the power of x squared times the derivative of x squared plus e to the power of x squared times the derivative of x squared is 2x. Whole thing multiplied by dx because we find the differential. So we have our du. Now this can be written as 2x e to the power of x squared is common, so we factor that out. That would be 2x e to the power of x squared times x squared plus 1 dx is our du. So we got our u and we have our du. What's our dv? Our dv is x over x squared plus 1 to the power of 2 dx. Well, to find v, we need to integrate it. So v equal to integral x over x squared plus 1 all to the power of 2 dx. And how do you integrate it? I just showed it to you. Use a substitution, x squared plus 1 equal to u. So substitute x squared plus 1 equal to u. That gives me 2x dx equal to du. The differential of x squared is 2x dx. Differential of 1 is 0. Differential of u is du. And therefore, what is your x dx? You can see I've used the colors there. When x squared plus 1 becomes u, what is x dx? X dx will be du divided by 2. So this will be replaced by u and x dx will be replaced by du over 2. We have now integral 1 over u squared du over 2, and that 1/2 comes out. It'll be 1/2 integral 1 over u squared du. Alright, I've been asking you this many times. What is integral 1 over u squared du? You can actually use the power rule there, but that is the standard integral that you can remember. Integral 1 over u squared du is negative 1 over u. There you go. So that will be 1/2 times negative 1 over u. And we replace our u now. U is x squared plus 1. So our v, we have been looking for v, and that's our v. V is negative 1 over 2 times x squared plus 1. Alright, I filled this page with our u, du, dv, and v. We have now all those 4 things. Alright, let's carry those 4 things to the next page. We are integrating this, and we have identified our u, we have now our du, we have our dv, and now we have our v. So we go and use the formula. What's the formula for integral u dv? It'll be u times v, uv, minus integral v du. That's what we are going for. Alright, so we have our u, we have our du, we have our dv, we have our v. Keep a watch on this. And integral u dv equal to uv minus integral v du. Let's put all those things in there. So integral x cubed e to the power of x squared over x squared plus 1 all squared dx. That's our original expression. And we picked u and v like this. So that will be u times v. That's our u, this our v. And v is negative, so the negative sign will be x squared e to the power of x squared divided by 2 times x squared plus 1. I hope you understand that. U multiplied by v. Multiply these two quantities. That will be the numerator and that will be the denominator with this negative sign. So this is our uv minus integral v du. Look at that. This is v, that is our du. Since v is negative, that quantity is negative. And it will be, v will be negative 1 over 2 times x squared plus 1. That's our v. And this is our du. Alright. And if you notice here, x squared plus 1, x squared plus 1 will cancel. 2 and 2 will cancel. Let's cancel those. There you go. And therefore in the next step it will be x squared e to the power of x squared over 2 times x squared plus 1 plus integral, what is left here is x e to the power of x squared dx. That's the only thing left over there. And this can be integrated. How? Tell me. I say emphatically that can be integrated. How? Tell me how you can integrate this. Well, look at the power x squared and look at x dx. Does a light go on in your brain? It should, because you can now substitute u equal to x squared, and then du will be 2x dx. You can replace x dx by du. So immediately you must see that this can be integrated by a simple substitution. So we substitute what? Substitute x squared equal to u and find the differential of both sides. It will give you 2x dx equal to du. Now when x squared becomes u, then what is x dx, the remaining term? X dx will be du over 2. So this integral now becomes, this term is going to remain the same. So that will be whatever we have here plus integral e to the power of x squared becomes e to the power of u, and x dx becomes du over 2. Now look how simple it became. And that 1/2 will come out. That will be 1/2 integral e to the power of u du. What's integral e to the power of u du? It will be e to the power of u. So that will be e to the power of u times that 1/2. And we put back that u. What is our u? U is x squared. So that will be x squared e to the power of x squared divided by 2 times x squared plus 1 plus 1/2 e to the power of x squared plus c. And we can factor out something, can't we? Yes, let's factor out e to the power of x squared. You can see e to the power of x squared in both cases. And I'm factoring out 2 times x squared plus 1 on the denominator. Now, how can I do that? When I take out on the denominator 2 times x squared plus 1, that is in here, but x squared plus 1 is not here. That means the numerator will get multiplied by x squared plus 1. Is that right? So, watch again. We take out e to the power of x squared divided by 2 times x squared plus 1. Let me see if I can show that to you on the board. Well, we're going to take out this, and in the next one we don't have an x squared plus 1. So what I'm going to do is multiply x squared plus 1 on the numerator and also on the denominator. Now, you can see this is going to come out. Alright? Now, what I've done is in the second term, I multiplied the numerator by x squared plus 1, the denominator by x squared plus 1, and what have you taken out? E to the power of x squared over 2 times x squared plus 1 here, e to the power of x squared divided by 2 times x squared plus 1. That's going to come out leaving in the first term an x squared. Is that right? And in the next one,